Here we have the function x squared divided by x squared minus 16, and this is what the graph looks like. So it looks like for the graph from the left side up to negative 4, the graph is going up, and then from negative 4 to 0, the graph is also going up, and then from 0 to 4, the graph is going down, and then from 4 to the left side, to the right side, or 4 to infinity, the graph is going down. And so that's what we want to find. We want to find where the graph is increasing and where it's decreasing. So first, find the derivative, and then find the critical numbers, and then that will tell us exactly what this value is and this value is. Here we have a quotient, and so to find the derivative, we need to use the quotient rule. And so the quotient rule is would be the bottom times the derivative of the numerator, and then minus the denominator minus the numerator times the derivative of the denominator, and then denominator squared. The derivative of x squared, that's just going to be 2x. And then the derivative for x squared right here is 2x. Derivative of 16 is 0. So we get 2x minus 0, which is just 2x. And then 2x times x squared, that would be 2x to the third. 2x times minus 16 is minus 32x. And then minus x squared times 2x, and that would be 2x to the third. And then right here we can see that 2x to the third minus 2x to the third is 0. So what's left is just minus 32x. And then to find critical numbers, first we looked at the derivative function here and see what will make the bottom here 0, because that's where the derivative is undefined. And that's where the function, that's where this function right here is not differentiable. And so right here we can see that if we let x be 4, and then we get 0. And so in the place of x, we put 0, 4. And so here we get 128 negative, and then this is 16 minus 16, which is 0. So we're dividing by 0, which is undefined. And then similarly, if we let x be negative 4, then we also get undefined. Because negative 4 squared, 16, 16 minus 16 is 0, and this is undefined. And so again, when the derivative is undefined at 4 and negative 4, then we say that this function right here is not differentiable at x equal to 4 and x equal to negative 4. And so we have critical numbers. And that's what we're seeing right here. We're seeing the negative 4, and then we're seeing 4. And then the other way to find the derivative, the critical number, is set the derivative equal to 0. So once again, two ways to find critical numbers. Look at the derivative here, and then find values that we can let x be so that the denominator here is 0. And then this one is obvious enough that we can let x be 4 or negative 4. But when it's not obvious, then what we can do is just set this denominator right here equal to 0 and then solve for x. And then that will tell us where the derivative is undefined, and hence tell us where the function is not differentiable. And then the second way is to find critical numbers is we set the derivative equal to 0 and solve for x. The reason we have to do it both because that's the definition of critical numbers. So critical number is defined as a value where the function is not differentiable and where the derivative is equal to 0. So that's why we have to do both. And so right here, this quotient is equal to 0. The only way that this can be 0 if the numerator here is 0, meaning the minus 32x has to equal to 0. That's the only way that this quotient right here could be equal to 0 if the top is 0. And so dividing by negative 32, x is equal to 0. So this is also a critical number. And that's what we're seeing right here. So we have three critical numbers. So we have the 0, the negative 4, and the 4. And so what we're seeing on the graph is this. This is negative 4, this is 0, and this is 4. And then that will help us figure out where the function is increasing and where it's decreasing. And so from the left side up to negative 4, the function is going up, so it's increasing. And so we say that f of x, which is this function right here, is increasing on the interval from negative infinity to negative 4. And then from negative 4 to 0, the function is also going up, so it's also increasing. It's also increasing from the interval from negative 4 to 0. And then from 0 to 4, the graph is going down. And then from 4 to the right side, the graph is going down. So that's why it's decreasing. So it's decreasing on the interval from 0 to 4. It is also decreasing from 4 to the right side, which is infinity. So from the graph, we saw that the function xy over xy minus 16 increases on this interval, and then increases on the interval from negative 4 to 0, decreases on the interval from 0 to 4, and decreases on the interval from 4 to infinity. So once again, with the derivative test, the first derivative test, if we pick any number inside of this interval and then evaluate the derivative at that number, then we get a positive value because the function is increasing on that interval. So let's say we pick the -5. So we pick -5, then here's the derivative function here. So in the place of x, we put -5, -5, -5. And then evaluate this right here, simplify this on the scientific calculator, then we get a positive 1.97. And again, we're getting a positive value because the function is increasing on this interval. And same thing here, if we pick a number from this interval, let's say we pick -3. And if we pick -3, and so in the place of x, we put -3 and -3. And then evaluate this, we get positive 1.95. And again, the reason the derivative is positive because on this interval, the function, this function here is increasing. And then the next two intervals, we should get negative value for the derivative because the function is decreasing on these two intervals. And so here, let's pick the 1 on this interval. And so we plugged in 1 in the place of x. If we put 1 and 1, and then evaluate this, then we get negative 0.14. And then the last interval, 4 to infinity, let's say we pick the 5 from this interval, and then 5 here, so for the derivative, if we plugged in 5, and then we get negative 1.97, which is negative.